So in this video, we're going to continue on the theme of histograms and focus on reverse questions. And this is where you are given a histogram and you need to read information or work backwards in order to find the frequency or other information that you would usually expect in a given question when you're asked to draw a histogram. Now, depending on what level of matter you are working with, at higher levels, sometimes you may be given a histogram and you need to work backwards to complete the information in a group data table or work out the frequency of a particular group. Now, what we're going to do is going to go through an example where you are given a histogram and you need to complete the table. So looking at this now, in terms of the first column, it's recognizing what headings are we putting in this table. So I would say in terms of the first one, we're going to put our groups, which in this particular example is based on wages. So I'm going to write wages, and the units of that are in the thousands of pounds. And then we're going to put the frequency, and then we're going to put the frequency density of this. Now, in terms of the first column now, you might get some marks just for completing the first, each of the columns. So what we're going to do first is do the easiest, which we don't need to do any math of this, is just reading the widths of each of the bars. So the first one is 10 to 15. Now, we don't quite know what the inequalities are, so we can kind of just guess. Now, typically you tend to find that the upper bound has the where it can equal, but again, it doesn't really matter as long as you're grouping 10 to 20. That's all that matters. And obviously, by using inequalities, we're not having any overlaps. Now, the letter W again is just representative of what the actual data, what the group actually represents. In this case, it's wages because of the W, so that's why we're going for W. But if you were to write X or whatever letter in between, you shouldn't really be losing any marks. So in terms of this, we go to our next group, which is 20 to 25, and then we've got 25 to 40, and then we've got 40 to 42.5, and then we've got 42.5 to 45. I think I just said 45 twice, but you know what I mean, 42.5 to 45. Now, sometimes in a table you might be given an extra few rows. That's not there to catch you out, it's purely there to test your understanding. So you may be given extra, if you are given extra rows, leave them blank. Don't feel the need to fill every single sort of row and column that you've got. Now the next easiest column to fill is the third column, which is the frequency density. Now we've been given the frequency density, so for this all I need to then do is read off how tall each of those bars are going to be. So for this one, for the first one, 10 to 20, it's going to be 0.7. For 20 to 25, that's going to be 2.4. For 25 to 40, it's going to be roughly around about 3.4, I make it. For the next one, 1.6. And for the last one, I make it out to be roughly around about 2.8. And again, all I'm doing is just reading off how tall each of those bars are to get my frequency density. Now, in terms of working out the frequency, what we need to now do is work out the area of each bar. So let me just make a little quick note of this. So the frequency, and this is the main property of a histogram, is that the area of the bar is basically how much there are in that particular category, or the frequency of that category. So the frequency equals the area of the bar. Or what you could use is the actual formula, which is going to be the frequency density times the class width. Now we've not mentioned the class width, so it's entirely up to you which one you want to go for. So if I went for class width and just write it in green on the side of the table, that would be 10, 5, 15, 2.5 and 2.5, like so. So to work out the frequency, all I need to do is either work out the area of each of these bars, so working out the area of this. So for example, the area of that first bar is going to be 0.7 times 10, which would give me the answer of 7. Alternately, all I could do is just simply multiply the class width by the frequency density, and if they're nice numbers you can work it on your calculator. If not, we just need to work it out using paper or your head even. So the next frequency will be 2.4 times 5, which is 12, The next one will be 3.4 times 15, which is 51, and 1.6 times 2.5, which is 4, and 2.8 times 2.5, which is 7. And there we go, we've completed our table. Now just be wary that a question might ask you specifically for a particular group. So a question might ask you how many people earn between the wages of 25 to 40, in which the only thing you would need to do is work out the area of this bar. You won't need to work out the area of every single bar if they're only asking for one particular group. So always be mindful, always check the question and make sure you're only answering what they're asking. So then let's move on to another example. So this one's very similar, but here we've got quite a few things that are missing, and it's important that we establish what it is that we've got. Now, one of the key differences with this is the fact that our frequency density, there's no numbers along that column, so I'm going to have to sort of work with that. But again, the first thing I need to do is label the headings in my table. So first of all, we're going to look at speed, and that's given in kilometers per hour. And then we're going to have frequency density in our third column. Now, the first thing I can do straight away is work out what the frequency density is for the 140 to 150. Now, if the class width is 10, then working out the frequency density, if you remember from the previous video, is the frequency divided by the class width. So that's going to be 50 divided by 10, which is 5. So that means that this bar here, if I just highlight it in red, so the 140 to 150 needs to be 5 up. Now if you count in terms of the squares, we're actually going up 5 squares, and that gives me the height here. So that means that this point here must be 4, that's 3, that's 2, that's 1, and that's 0, and then that would be 6, that would be 7, and that would be 8. But again, we don't really need to go that far because there's no bar that goes beyond 7. So now what we've done, by using the results of what the information we've been given in the table, we've now been able to label the frequency density sort of scale. And now what I can do is I can now complete the table just in a very similar way as I completed the first example. So the first thing I'm going to do is fill in the first column. So the first column we've got is 80. And again, here you can see that the equal sign is on the lower bound, which again doesn't really matter, but I would certainly look at the tables and just try and emulate whatever they've written. So that's 100. Next group is 100 to 140. The next one is 150 to, and it'll be 170. And the last one is 170 to 210. So the next thing I then need to do is now work out what the frequency densities are for each of those bars that I've not been given information from. So working that out, again, all I'm doing here is simply just adjudging, having a look to see how tall each of these bars are. So the first bar is 2.6. I'm going to write 2.6 here. The next bar is 0.6, I make it. The next bar is 6.2, and the last bar is 4.4. And again, all I've done there is just judged how tall each of those bars of what they actually are, and that's 0.6. So the next thing I've then got to do is work out the frequency, and again you can work out the frequency by either doing the area of the bar, so this one will be 20 times 2.6. The next one would be 0.6 times, and the width is 40. This one here is 5 times 5, or 5 times 10 I should say. Let me just go back and correct that. The next one is 20 times 6.2, and the last one is 4.4 times 40. But again, what you can do is from the table, we can work out the widths. That's 20, that's 40, that's 10, that's 20, that's 40. And then what I'm going to do to work out the frequency, I'm just going to multiply the class width by the frequency density. So let's just write that out again. So the frequency is equal to the area of the bar, or the frequency density times the class width. And again, it doesn't matter which one you go for, it's entirely up to you which one you prefer. If your graph is a little bit sketchy, or the photocopying is not great, or the scale, you can't really see the lines, then definitely opt for working with the class width times the frequency density, because that will make life just that little bit easy. So in terms of filling in the numbers, we get 52 for the first one, we get 24, we get 124. Oh, I don't know why I wrote 125. Let's get rid of that. 124, and then finally 4.4 times 40 gives me 176. And again, looking at my scale, it's worth just double checking to make sure, does it seem right? Well, the biggest area is the last bar, and that gives me the highest frequency, and the area with the least amount of area is probably 100 to 140, and you can see there that that's got the lowest frequency as well. So it's all looking good. And again, just make sure that you're reading the questions carefully. Like I said, big mark questions will ask you to complete the whole table. 1 or 2 mark questions would ask you just to work out one specific group that you just need to work out the area for, or work out the class width, work out the frequency density, and then just multiply the two numbers together, and you are done.